All right, hello everyone. Geometry, Unit 3, Lesson 5. Objectives for today are to determine if 3 given side lengths can be used to form a triangle, to determine a possible range of values for a third side given 2 other sides, and then we're going to look at ordering the angles from smallest to largest or largest to smallest based on side lengths given, as well as the other way around. So let's go ahead and get started. All right, so let's talk about what's called the triangle inequality. As you'll notice here, I've got some triangles drawn on the left, and then some attempts at triangles drawn on the right. If I were to label sides C and B and A, or C and B and A, or in the third one, which I'm not going to try because that's so dang small. Looks like a little fish hook. What you'll notice is that the 2 shorter sides come up to be less than the third side if I add their lengths. Right? That's what the triangle inequality is attempting to say, is that any 2 sides of a triangle must add to be greater than the third side. This is what we want to happen. This will allow for there to be a creation of a triangle. Okay, and for that matter, it could be any of these matchings. So it could be the length of A and C have to add to be greater than B. So the triangle inequality is any 2 sides has to be added to be greater than the third side. And in the examples on the right side, that's not true in any case. So let's look at the next slide and look at a few examples. Would the following form a triangle? Okay, so 2 and 4 and 5. Well, would that form a triangle? I could do 3 inequalities. Let me just sketch this. I'm going to put the longest side on the bottom, so 5 centimeters. I'm going to put a 2 here. I'm going to put a 4 here. And hopefully I've drawn this to scale. But if I were to try to form a triangle, I would just try to match and meet those 2 points. Well, if I brought them down right here, it looks like I would be able to form a triangle. Whoop. And they would meet at this point. Okay, so we could say, yes, that would form a triangle. How about 5, 5, and 7? Let's put the longest side on the bottom, 7, and 5, and 5. This is cool because what this will do is form an isosceles triangle, which we have talked about. So visually, I would take those 2 points, try to connect them, and I would find that I would be able to form this isosceles triangle here. It's interesting. So yes, I could form a triangle out of that. The third example, 12, I would have a 6, and let's go 4 here. Let's go 6 here. We would have issues, right? As I drop these 2 side lengths down, right, my red side would end up here, or my red point end up there, and my blue point or green point there. So of course I can't form a triangle there. Let's confirm that each of these 3 examples is true now using the triangle inequality. So formally stating the triangle inequality, we see that the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. Specifically in this case, I'm going to take the 2 shorter sides, add them up, and see if they're longer than that longest third side in their sum. So I take 2 and 4, add them together, I get 6. So question is 6 greater than 5? Yes, it is. Okay, therefore, a triangle exists. Okay, how about 5, 5, and 7, or 5, 7, and 5? I'm going to take 5 and 5, the 2 shorter sides, add them together, I get 10. Well, is 10 greater than 7? Yes, it is. Therefore, again, a triangle exists. Okay, our last example, I'm going to take 4 plus 6, that equals 10. Now 10 is less than 12. That's a no-go, right? We don't want for the sum of the 2 sides to be less than the third side. We want it to be greater. Therefore, no, triangle does not exist. Okay, this is the symbol for does not exist. So when I'm trying to see if a triangle exists given three sides, I would take the smallest side plus the, I guess you could call it medium or the middle length, and confirm whether it's greater than the largest side. That's your goal when trying to confirm whether or not three sides can form a triangle. Now, if the small and the medium are the same length, or if the medium and the large are the same length, or all three are the same length, I guess it kind of muddies that idea, that concept. But you're just taking any two sides, showing that it's greater than the third side when you add them together. Okay, let's look at another example. Okay, here we go. Here's an interesting example. Given that two sides of a triangle are 4 and 7, what is the range of possible values for the third? So I'm going to call that third side x. So my triangle would consist of x and 4 and 7. So what I'm going to consider, and I'll tell you why in just a moment, is that x is the smallest possible value. So let's consider that x is the smallest. Well, using the triangle inequality, what I would do is take x plus 4 and just ensure that it's greater than 7. Well, solving this inequality, I would subtract 4 from both sides. So that tells me that x has to be greater than 3. X can't equal 3, but it has to be greater than 3. So the smallest, or the lower bound for the value of x has to be at least, well, not at least, don't use the word at least. It has to be greater than 3. Let's find the upper bound. Now, instead of saying that x is then the middle length, right, if I used x as the middle, it's not going to help me any. Right, and here's the reason why. If I said x was the middle length, then that'd be 4 plus x greater than 7. So that would yield for me the same inequality. So I don't want to use middle. Don't use that. What you want to use is the largest. Let's say that x is the largest value in those three lengths. So if x was the largest, then we would say that 4 plus 7 has to be greater than x. So that means x has to be less than 11. So the upper bound for the value of x is 11. X has to be somewhere between 3 and 11. Can't equal 3, can't equal 11. Now, a little shortcut alert. Okay, let's go blue. Let's see if this shows up. Okay, yeah, it shows up. Okay. How do we get 3 from 7 and 4? Well, we subtract them. How do we get 11 from 7 and 4? We add them. So if you take the two given sides and you add them together, that gives you your upper bound, in this case 11. If you take the two given sides, subtract them, that gives you the lower bound, in this case 3. Let's look at an example of that. Okay, here's example 3. Given that two sides of a triangle are 38 and 29, what is the range of possible values for the third? Again, I'm going to call that third side x. Okay, I could set up the inequality, and I could say x plus 29 has to be greater than 38. And I could set up another inequality, so this would assume that x is the least, or the smallest. All right, and then I could set up x being the greatest, or largest. And then set up the inequality 29 plus 38, right, is greater than x. Or I could take 29 away from 38, give me my lowest, or my lower bound for x, so x has to be greater than 9, and then 29 plus 38, which will give me my upper bound, which is 67. Ultimately, that's what I'm doing. That was a weird 7. Let's try that again. That's what I'm doing here. X is greater than 38 minus 29. Look at that. And here, x is less than 39 or 29 plus 38. All right, so if you're ever asked the range of possible values for the third side, take the two numbers given, add them, take the two numbers given, subtract them, make sure that both values are positive, because side lengths have to be positive, and you got your range of possible values. All right, let's look at a couple more examples. Okay, here we have the side angle inequality conjecture. In a triangle, if one side is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. So let's identify the smallest and biggest angles in the triangle below. All right, clearly 32 is the smallest angle. 94 is the biggest angle. And that leaves 54 right in between. Our example is asking us to list the sides of the triangle in ascending order. So that's least to greatest. Okay, I want to list my sides in order from least to greatest. So across from the smallest angle, this is what the side angle inequality conjecture is telling us. Across from the smallest angle is the smallest side. So DE is our smallest side. Our largest side is going to be the side across from the largest angle, which will be EF. And the side that kind of lands right in between there would be the side DF, which is across from the angle that is not the smallest and not the largest. Okay, let's look at an example that takes this to a little bit more complex level. Okay, so this is not more complex. I was thinking of the example coming on the following page after this. But this inequality also works with when we're given side lengths. So as I look at the triangle given, I can see that the largest side is AB. It's 5 centimeters. The shortest side is BC. It's 3 centimeters. And the side in between those two is AC, 4.5 centimeters. It wants me to list the angles in the triangle in descending order. So descending order means greatest to least. So I want my largest angle followed by the next smallest followed by the smallest. Okay, so as I look at my side lengths, I can clearly see that my longest side is this side AB. Our longest side will always be across from our greatest angle, or biggest angle. That would be angle C. Our smallest side will always be across from our smallest angle, angle A. And in this case, our side that's in between will be across from the angle that's in between those two, which will be angle B. So this idea of ordering from greatest to least, either angles or sides, can be applied to both scenarios. Let's look at our final example. Okay, I'm going to look at example 6. I've got two triangles that share a side. And as I look at these triangles, I'm going to name one of them triangle 1. I'm going to name the other one triangle 2. So you can see that triangle 1 and triangle 2 share a side, side C. And as you look at the triangle, you can see that triangle 1 is smaller than triangle 2. So the angles of triangle 1, or excuse me, the sides of triangle 1 are going to fit within those 3 spaces. The sides of triangle 2 are going to fit between those 3 spaces. And the side that's shared will be side C. Right? You can see how those two triangles share that side. So what it asks us to do is list the sides of these triangles in ascending order. Okay, so in ascending order would mean from smallest to greatest, hence why triangle 1's sides are on the left and triangle 2's sides on the right. So I got to do a little work to find some angle measures. Thus, within each triangle specifically, I can order the side lengths. So let's look at triangle 2 first. I can see I've got an angle of 33 here. I got an angle of 38 here. And I'm going to call this angle right here X. And I'm going to make an assumption, pretty safe assumption, but an assumption as it is, that X will be a different measure than 33 and 38. So 33 plus 38 plus X, triangle angle sum conjecture, should equal 180. 33 and 38 is 71. And I subtract 71, that gives me x equals 109. All right, so if x is 109, that is the largest angle in that triangle. Therefore, D is the largest side in that triangle. That makes E the side in between. Okay, let's do a little work in triangle 1 now. Notice that I've got a 38-degree angle here and a 90 here. So this angle right here should be 90. Oh, my Apple Pencil. Okay, hang on. I'll be back. Okay, I'm back. Should be 90 minus 38. So 90 minus 38 equals 52. So this angle is 52 degrees. Now within the context of triangle 1, I see an angle of 52 and 89. I'm going to do this in black. It looks like red is not showing up very well. So 52 plus 89 plus, I'm going to call this angle right here angle Y, should equal 180. I add 52 and 89, I get 141. When I subtract 141, I get Y equals 39. Okay, so if Y equals 39, all that I need to do is determine side lengths. Is A bigger than B or is B bigger than A? So since this angle is 52 and this angle is 39, side A will be the shortest side, side B will be the next side in order from least to greatest. And there you have it, guys. Now, at some point, it may be difficult to determine which triangle is larger. And most of the time, it's pretty easy to tell. But in this case, you want to compare the side that is shared with the angles, okay, with the angles that are across from those in both triangles. Now, this is counterintuitive, but the angle that is smaller, right, is in the bigger triangle, right? So 33 degrees opens up to the same side that 89 degrees does. So what this tells you is that C is the biggest side in this triangle and the smallest side in this triangle. So if you're the biggest kid in a group of people, but the smallest kid in another group of people, you can tell which of those groups of people would have the larger individuals, right? So just a contextual comparison there. But I hope this lesson went well. Let me know if you got any questions. Otherwise, we'll see you in the next video.